Prototyping a game allows us to get to the action quickly. We'll have our hands on a fully playable version of Traffic Department in a few hours by relying on the commercial game engine, GameMaker Studio. I'll spend a few minutes discussing why we're using an engine, and then we'll do preliminary work setting up the environment for the game. Software engineering is about problem solving, and since game development is a subset of software engineering, making any game has its fair share of problems to solve. And believe it or not, most of the solutions we need aren't specific to the game at all. So to get something playable within a few hours, I want to confine those problems to those of Traffic Department itself. Using a commercial game engine allows us to do just that. We can cut the challenges of game development in many ways, but here's the one that illustrates my point. There are problems common to all software programs, such as memory management, basic device I/O, platform independence, complex math, and programmers use libraries and software development kits to solve these problems quickly. Then there's problems common to almost every game, like asset management, which covers the sounds and images, and other assets like we've already extracted. There's pathfinding problems, AI problems. Most games consider some physics issues like collision detection in 2D, or rigid body dynamics and kinematics in 3D. And this is where game engines come in. They provide solutions to common problems game designers have to solve. Game engines allow us to focus only on the final class of problems, those specific to our game, which in our case is Traffic Department. Examples of Traffic Department problems include how to drive the dialogue sequences based on user input, or how to draw the city based on what we know from the map files and the BLK files. Now, I've chosen GameMaker Studio because it gives us many different ways we can approach the problems, and I'll use a variety of approaches on each part just to keep things interesting. The engine is very well suited for 2D games of this style. Now, in reality, GameMaker is far more capable than what we'll use it for, which is why we'll be able to go from 0 to fully playable in a few short hours. After we finish prototyping a close replica of the game, we'll add some easy enhancements, which is the benefit of fast prototyping. Get the game working, learn ways the original idea could be improved, and then improve them. After we've solidified the prototype, freeze the features and move on to a more custom engine based on the exact needs of the design. So now we're going to create our project in GameMaker and do some preliminary tasks, such as loading some assets that we've already extracted. I'll also walk through some of the most important abstractions that GameMaker provides to make our job easier. I'll also mention that GameMaker is free for general use, although you have to pay for the ability to export to certain platforms like HTML5, iOS, and Android. Anyone should be able to follow along and create a game that's fully playable on their home PC without any cost. Let's create a new project and call it TD2192 Prototype. Now in the IDE, we have two areas that we'll spend most of our time. The empty space on the right is our workspace. We'll open up code windows and do scripting in the local language of GameMaker, that's GML. The left side is an interactive resource manager where all of our project assets live, to include the code containers that we'll create over time. When we create or add a new asset, the asset or the object prototype appears over here. It's similar to the project window in Unity. One thing to remember is that any asset in the resource manager gets added to the global namespace, and so there can't be any duplicates. So make sure to use a distinct naming convention. We'll probably only use about half of these resource types, so let's climb down the list. Now first there's the sprite folder where we keep all the graphics assets. All the graphics we put here are automatically arranged into texture pages, which we can organize further for efficiency if we need to. For now, let's load up the SCR files by creating a folder under sprites called SCR, then dragging all the SCR assets from our extraction workspace. That's it. From now on, we'll just load the assets as we need them. We'll use the SCR files in the next couple of videos. Now, I gave the assets an extended name, which guarantees no namespace collisions, but it may be messy. I won't worry about it for the SCR files for now. After sprites or sounds, again, we can simply drag in the sound files. It'll ask us if we want to store them as sounds or as included files down here at the bottom. The most important difference is how the files are packed. This time I'll change the name to get rid of the prepended asset class. I'll lighten these up a bit since I plan on hosting the final result on the internet. Let's knock them all down to mono 16-bit at 24K. My lowest priority is runtime memory usage. Next we have the backgrounds asset class, which I don't think we'll use. I believe it does have features supporting sprite sheets and fast runtime access. I'm really just going to rely on the sprite assets combined with surfaces, which is how we'd end up handling it if we did this manually without an engine anyway. Paths we won't use. I'm not sure I've ever used it, but it's here, so it must be useful. Scripts we'll use, and they are interesting. We'll use them to create our own globally accessible commands used in regular GML code. I think the most important thing to know about scripts is that they have dynamic scope and inherit the visibility of the calling frame. Now, although scripts can locally override variables, they can access the same information owned by the calling object. Any variables that the script defines non-locally will continue to exist in the caller after the script ends. Scripts can be dangerous, especially if you couple them with specific objects and events, because the interpreter wouldn't know this. We'll make dangerous use of these. Now, shaders we won't use, but they are fully supported. I believe you can even use the OpenGL shader language. Probably too powerful for our needs. Fonts we will use, but not with this built-in asset class. We'll load our own fonts as regular sprites and manage them at runtime. Timelines, I admit I have no idea what they're for or how they're useful. We won't be using them. Now, objects are the meat of the game. They're abstract code containers that execute based on events dispatched by the game engine. It may be helpful to think of them like classes, because objects are only prototypes that have to be instantiated. A single object can have any number of instances. Unlike classes, the objects are strictly procedural and can't have methods associated with them, but combining procedural code with the dynamic scope scripts can emulate object-oriented behavior pretty well. Objects include a few built-in parameters for simplistic physics that can be extended if need be. There's dozens of events that you can associate with objects, including the classical constructor and destructor. There's even a concept of parent objects, which opens the door for inheritance. GML has commands to enable executing arbitrary code from any object events, so you can flirt with polymorphism if you want. I won't be doing much of that in this project. GameMaker's concept of objects provides enormous flexibility, most of which we won't need. Rooms provide the setting for each distinct part of the game. Every game has the concept of a room, but we usually call them stages or levels. I think both the Unreal Engine and the Cry engine call the room concept levels. Unity calls them scenes. Construct calls them layouts. It's all the same idea. You put all the objects in a room and press play and the game plays out. The goal in most games is to get through the rooms in sequence. In GameMaker, the room abstraction is responsible for setting the visual and spatial properties of the game. We'll start with this soon. Finally, we have included files. We'll use this for generic file access for assets that aren't graphics or sounds, like the map files or the dialogue. Maybe we'll even create some files of our own. Just drag and drop. The remaining things on this list we won't use. We'll make some changes down here in the game settings, though. Now, the most important abstraction that GameMaker provides isn't listed here. GameMaker and all other game engines provide a game loop out of the box, and good game engines allow us to customize that loop as needed. Now, the game loop is the feature that separates a game engine from specific libraries and toolkits, like SDL or SFML or Allegro. All game object code binds to some point in the game loop. My impression is that when an object is instantiated, all the code blocks defined in that object event list are registered with the game engine, and it runs on demand. Now, the details aren't really important right now, but you can look up event order in the help file and get more information. In general, the game loop follows convention. User input is processed early, objects are updated, and then the room is rendered to the screen. We have the freedom to choose what happens around all of those fixed points. I think that's all I wanted to cover in this video. The next dozen videos will alternate between laying down the prototype design in PowerPoint and then implementing it in GameMaker. Most of my design choices will be completely subjective. Some will include ideas that are highly reusable, and some will only ever apply to this game. Unusual solutions are part of my personal motivation for getting through this project. Thanks for watching.